Hello everyone. Today we are tackling the rectangle and the rhombus. Now rectangle is something you guys have probably heard about for a while. This is something you learned back in, elementary school maybe. But we're going to dig a little deeper into the mathematics of it, throw a little algebra in there, make it a little bit more upper level, and test out your critical thinking in that way a bit more. I know you guys are winding down the school year. We got about 10 days left, but make sure to stay strong. Keep working on this stuff. We've got one last quiz to tackle before we finish up the school year. So make sure you're still staying on topic and working hard. So let's get started. So this notes page, I kind of decided to do something a little different, because why not? You can feel free to color on it, make it look fun and cool and pretty and doodle on it. Obviously, don't let that take away from your actual learning, but if you want to spruce it up a bit, go for it. We're going to tackle the rectangle first. A couple things to know about the rectangle. It is still a parallelogram, so those four characteristics we've been digging into day after day, the last couple days, they still apply. It's just that now it specifically is a parallelogram with four right angles, and there's a couple things that come along with it that make it kind of special. Here's our little rectangle picture. We'll get into the actual diagram in a second. So make sure you're copying down the things in red. The opposite sides are still congruent and parallel. That's one of the characteristics we've already learned because it's a parallelogram. And the diagonals bisect each other. And this time, what's kind of special here, and maybe you want to highlight these or circle them somehow. The diagonals being congruent is new, and the four right angles, those are the two new pieces of information for the rectangle. The rest of it is stuff that we would have already known because it's a parallelogram. Those are the two things that are brand new. So as I'm looking at my rectangle, there are some things that I can fill in because of this new info. Oof, that was a bad line. Maybe I should just cheat and use the actual symbol. Here we go. Totally cheating. Sorry, you can't do it on yours. All right, so let's draw our diagonals in there. Mine looks so nice and perfect. All right. Now, because it's a parallelogram, we already knew that the opposite sides are congruent, so I should mark those. My little tick marks there, and then some double ones there. And they're also parallel. Well, the symbol for parallel is the arrow. So I'm going to do, actually, let's undo that. I'm just going to make it look like that. And then these are parallel as well, but since they're a different set, we're going to do double arrows. These diagrams get a little bit crazy. Don't get overwhelmed by it, just one step at a time. So we took care of the opposite sides being congruent and parallel. I'm going to put a little check mark right there. Let's go back to the beginning. I forgot this part. The four right angles, that's the new piece of information. So that means this is a right angle. Ooh, that was really badly drawn, my bad. Pretend that's a nice box. And there we go. All right, so all those four angles are right angles, and therefore they're equal to each other. Obviously, we're talking about this entire angle, not just these little tiny ones right here. So that guy's done. Woo, that was a crappy check mark. I'm just failing at this. All right, the diagonals bisect each other. If you forgot what that word means, write it out. Bisect means to cut in half. If you cut something in half, the halves must be equal to each other. That means that this guy is equal to this guy. And 1, 2, 3, 4. 1, 2, 3, 4. My goodness, this pen is just crapping out on me. Those all are equal. And in fact, because the diagonals are congruent, I'm going to get rid of one of these little lines. Because all four of these little segments, 1, 2, 3, and 4, are all equal to each other. So I don't need to do 3 and 4 little tick marks because they're all the same because the diagonals are congruent, which means from here to here is equal from here to here. Okay? Now, because of those handy-dandy rules about rectangles, there's one other one that we should know. Da-da-da! Right here. The diagonal of a rectangle divides it into two congruent triangles. So when I have my lovely rectangle, which was poorly drawn, and I cut through with a diagonal, I automatically have one triangle and another equal triangle flipped over it. So they're totally the same. The side lengths are the same. Obviously, they're a bit reflected, so they go like that. And then there'd be the right angle. So you could use Pythagorean theorem. You could use trig. You could use all this crazy stuff. You could use the fact that they add up to 180 degrees. We're not especially going to dig into that today, but just so you know, that's an option in there. So fill that in. And then we're going to flip over to the back side and start digging into some examples so that you guys can knock out that assignment. So we are just going to tackle the rectangle section, obviously. So number one, start with the basic stuff. AE is 3. Well, AE is this little tiny line right there. Remember, our new pieces of information are that there are 4 right angles and that the diagonals are congruent. So I'm just going to mark those up just so I kind of know, since that's the new stuff that we haven't really learned in other parallelograms yet. That's kind of new. So if AE is 3, I'm going to look for BD. Okay, now if AE is 3, that means that BE is 3 and ED is 3. We'll put it together to make BD. That means 3 plus 3 equals 6. Woo! Oh, that was a horrible box. Okay, so that means BD is 6. Awesome. All right, so next one, angle BCA. Let's get rid of some of this craziness going on here. Let's get rid of that 3. Get rid of this stuff. Okay. All right, angle BCA. Oops. BCA is talking about just this tiny little angle right here is 42 degrees. Then find angle BAC. Means I'm looking for this guy. Okay. Now, those two look like they may not be in a place that can be very helpful to us, but take a look at the picture. Do you see a part of the shape that they are in the same shape of? That was poorly worded. In the rectangle, is there something that those two angles are both in? Hintity, hint, hint, hint. So I'd basically bold this in with a yellow line for you to see. Ta-da! They're a part of a right triangle. And I know it's a right triangle because there's this fancy little box right here. I know that this is 42. I know that this is 90 because it's a right angle. How many degrees do all 3 angles in a triangle have to add up to? 180. Still true with rectangles. So I've got 90 plus 42. Together that gives me 132. That means I need to figure out what is left out of 180. So that means that my missing angle, BAC, hopefully your guys' handwriting isn't as giant looking as mine is. That's an 8, 48 degrees. Cool. And if I put all 3 of those together, 48 plus 42 plus 90 would all add up to 180 degrees. Moving on along to the next ones, tossing in some algebra here. So we've got BE. Let's get rid of some of this stuff here. I'm just going to erase this whole craziness because it's getting too much in there. BE is right here, 6y plus 2, and CE is 4y plus 6. Well, what do I know about these two segments? Because these diagonals are congruent and because they bisect each other, I know this and this is the same, and these have to equal those as well because the diagonals bisect, like we talked about. This half equals this half, and since the 2 lines are equal, all 4 of those little lines are going to equal each other. So BE has to be congruent to CE. Well, how do I show that things are congruent? Congruent means equal to. If BE is congruent to CE, replace the stuff with the algebra and solve it. Gotta get those variables together. So move those y's along to the other side. So I have 2y plus 2 equals 6 over there, minus 2, minus 2. 2y equals 4. My handwriting is very large on this device. I apologize, I was kind of going everywhere. Hopefully you can follow that. That's really just the algebra stuff. But I get that y is equal to 2. If I was to plug 2 into both of them, 6 times 2 is 12. 12 plus 2 is 14. All right. 4 times 2 is 8. 8 plus 6 is 14. Cool. I get that they're both the same length, which is exactly what I wanted. Feel free to pause, rewind, go back what you need to do. Moving on to the next example. We're looking for angle BEA this time. It's telling us that that angle is 62 degrees. And I'm looking for angle BAC, this guy. All right. Well, let's think about the fact that these lines are congruent. I already drew those lovely marks in there. Earlier in the year, we learned about a type of triangle where 2 of the lines are congruent. It's not scalene, it's not acute, it's not equilateral. It is the isosceles triangle. And something special we learned about the isosceles triangle was that if you have 2 congruent angles, two congruent sides, then you have to have 2 opposite congruent angles. Well, BE is right here. Across from it is this angle. AE is right here. Across from it is this angle. That means that these guys, these 2 angles, have to be the same. And what do I know that all the angles add up to in this triangle? 180 degrees. I know I just threw a lot of info at you there, so feel free to rewind and kind of listen again if you need to. If not, I'm going to move on to the math part. I know that it has to add up to 180, and I've already taken out 62 degrees. That means I've got, let's see, there's 8 there. I believe that's right. Totally doing mental math, so hopefully I'm not screwing up on video. That would suck. Okay, 0. Yeah, I'm pretty sure we're good on that. Okay, so that means these 2 angles have to add up to 118 degrees. We just determined that they're the same degree, so let's split 118 into 2 equal sets. Okay, well, 100 divided by 2 is 50. 18 divided by 2 is 9. So they each have to be 59 degrees. And if I was to add 59 plus 62, I would get my lovely 180 degree triangle like I'm supposed to. Last one for the rectangle notes. A little bit more with angles here. So we're looking at AED this time. So let's get rid of some of this craziness going on here. This is why you should use pencil that we always tell you to use, right? Look at this erasing stuff. Comes in handy, huh? All right, AED is right there. Now look at, I'm still using my eraser. Go me. There we go. AED is 12x. Throwing back some algebra here. And BEC is 10x plus 20. So this is giving us a quick refresher on some stuff that we didn't remember possibly. Look at those 2 angles that I just drew. I'll even draw these lines in here just to kick in your memory. What type of angles are those? They're both at point E and they make kind of a V shape. Hopefully your brain is screaming vertical angles. What do you know about vertical angles? Oops, that was written badly. Hopefully your brain is screaming that they are congruent. If they're congruent, congruent means equal to each other. So let's set those things equal to each other. 12x equals 10x. Whoops, too many equal signs going on. This is what happens when you make a video late at night. 12. All right, 12x equals 10x plus 20. I kind of jumped ahead and did a lot of the math for you because I was cutting low on time. You cannot put these together unless you move this over to the other side. So subtract 10x over here. 12x minus 10x is 2x. So I get 2x equals 20 because 20 is still over here. How do you get x by itself? You divide both of them by 2. So x is equal to 10. Now, don't forget that you're actually solving for angle EAD. That means you got to take 10, plug it back in here, and 12 times x, since x is 10, 12 times 10 is 120 degrees. You're going to do the top part with rectangles on the homework page now.